Hello, today we'll be learning about shortest job first, non-preemptive scheduling. Check the previous videos to understand what is preemptive scheduling, non-preemptive scheduling, and also we have done a problem on SJF preemptive scheduling. Now, given the problem, we have processes and arrival time and burst time that is given. We have to find average turnaround time and average waiting time, and we also need to draw a Gantt chart. To start with the problem, we have to write a ready queue. It's easy with the ready queue for you to understand and see the how the process is standing in the queue and which process will be going inside the CPU. Now during 0th millisecond, that means when the CPU is already available during 0th millisecond, there is no process that is there inside the CPU and even the ready queue. I'll write the Gantt chart here. During 0th time, there is no process because ready queue is empty and there is no process that is arrived at 0. So during 0 and 1, the CPU will be in idle. During 1 millisecond, there is two process that is coming into the ready queue, that is P1 and P3. Now P1 and P3 is already there in the ready queue. We have to decide which is the process that is getting the CPU. So for that we have to check their burst time. So P1 has a burst time of 3 and P3 has a burst time of 2. So 3 and 2, P3 has a lesser burst time. So you'll be giving the CPU to P3 first and P1 will be inside the ready queue. So P3 goes inside the CPU. P3 executes for 1 millisecond, that is 2, and checks for any other process that has come. P2 has come that time. So P2 has come, which has 4 millisecond of burst time. We don't have to worry because 2 is the lesser one. So P2 goes and P3 goes and it completes for 1 more millisecond. Now 1 more millisecond is uh, at 3 millisecond, P3 completes the task. During 3 millisecond, there is no other process that came into the ready queue and P3 also completed the task. So P3 completed during 3 millisecond. Now we have P1 and P2. Check the burst time. P1 has 3 millisecond, P2 has 4 millisecond. So we'll be giving the CPU to P1. P2 remains here and there is no other process who has come. So P1 goes here and it completes the task for 1 millisecond, that is 4. So during 4th millisecond, there is a process called P4 that came into ready queue. P4 had 4 millisecond, P1 has lesser burst time. So we can continue 5 and 6. P1 complete the task at 6 millisecond. Now we don't have to check for the arrival time because there were 4 processes and all the 4 processes has come inside the ready queue. Now we have to check P2 and P4. P2 and P4, which is having a lesser burst time. Both P2 is also having 4, P4 is also having 4. So this moment when both the burst times are same, we have to check the order here. P1, P2, P3 and P4. If you see this order, which is the one who came first, P2 came first. So P2 will go here and P4. Even if you see the order here, you will get to know P2 came first and P4 came later. So we'll be giving the process to P2 first and it completes the task for 4 milliseconds, 10, and the next one is P4. P4 completes the task at 14 millisecond. If you see here, P3 had 2 burst time. It completed exactly at 2 and it eliminated from the CPU. P1 had 3 millisecond, it got exited from the CPU. P2 had 4 and P4 had 4. So in non-preemptive scheduling, we are not giving up the CPU to any other process, but we are completing the task that is given to the process and then only we are exiting from the CPU. So this is called as your non-preemptive scheduling. Now we have to find out completion time, turnaround time and waiting time, and the final Gantt chart is already written here. Completion time, when did P1 completed? P1 completed at 6, P2 completed at 10, P3 completed at 3, P4 completed at 14. Completion time is done. Now we have to calculate your turnaround time. Turnaround time. So turnaround time, the formula is CT minus AT. Completion time minus arrival time. Completion time, CT is 6, arrival time is 1. So answer is 5. This is 8. 3 minus 2 is 2. 14 minus 4 is 10 milliseconds. So this is turnaround time. Waiting time would be turnaround time minus the burst time. So waiting turnaround time is 5 and the burst time is 3. So 2, 8 minus 4 is 4, 2 minus 2 is 0, 10 minus 4 is 6. We have to calculate average turnaround time. 5 plus 8 plus 2 plus 10 divided by 4, because the number of processes 4 here. 25 divided by 4, the answer will be 6.25 millisecond. Average waiting time would be 2 plus 4 plus 0 plus 6 divided by 4. The answer will be 12 divided by 4 and 3 millisecond. So this is your shortest job, non-preemptive scheduling. In non-preemptive scheduling, we are not giving up the CPU for any other process. Even though the shortest job comes inside the ready queue, we will complete the task and then give to the process that has a shortest burst time. Thank you.